routine begins in silence, framed by the wide and lonely expanse of the Martian orbit. Out there, where the faint light of the sun begins to lose its warmth, and the cold becomes the natural condition of existence, a stranger slides into view. Not a spacecraft, nor a satellite born of human engineering, but an interstellar traveler whose home lies far beyond the reach of our most powerful telescopes. Designated 3I Atlas, this object cuts across the orbit of Mars at an astonishing 200,000 Neon, approximately 89.4 kilometers per second. This is a velocity so immense that the very numbers seem to slip away from intuition. Against the black velvet of space, Mars itself becomes a backdrop, a red sentinel illuminated by sunlight, and across its face streaks this silent messenger. No engine drives it. No guidance system plots its trajectory. Its movement is the outcome of unfathomable time and gravity's eternal pull, shaped in some star system that is not our own, ejected by planetary forces we can only imagine. To us, its appearance is a whisper, brief and almost illusory, a fragment from the beyond that offers itself only once before vanishing again into the galactic night. The mystery it brings is simple yet profound. What is it made of, and where does it truly come from? Each fleeting photon it reflects toward our detectors is a coded message from the deep past, from conditions we have never witnessed, perhaps from chemistry unlike any we have yet cataloged. To scientists watching from observatories on Earth and Mars, this encounter is more than an astronomical curiosity. It is a chance to probe the building blocks of other solar systems, to capture in one dim streak of light the physics of creation and destruction, the echoes of star birth and planetary violence. As it races past Mars, we confront the smallness of our own place, waiting for its secrets to be revealed in time, too short and distance too vast. If you want to be the first to know when the universe reveals its deepest secrets, you need to be part of this community. Hit that bell so you never miss a discovery. The cosmos is calling. Answer it with us. The story of 3I Atlas does not begin in the cold silence of Mars's orbit, but much earlier in the warm domes and quiet nights of Earth-based telescopes. It was the Atlas Asteroid Terrestrial Impact Last Alert System that first caught the moving shadow. Designed specifically to safeguard our planet from near-Earth hazards, the Atlas telescopes scan wide swaths of sky each night, cataloging stars, asteroids, comets, and the occasional anomaly. On one such night, in faint digital frames crowded with thousands of background points, astronomers noticed an object moving at a speed and trajectory inconsistent with a typical solar system body. The initial positional data, collected by the twin Atlas telescopes in Hawaii, hinted at something extreme. This was no ordinary asteroid bound to the sun by familiar elliptical chains. Instead, the orbital solutions suggested a path that refused to close, an arc so energetic that the sun's immense gravity could not hold it. From this first glimpse, urgency spread through the astronomical community. In science, nothing travels alone. Every detection demands immediate verification. Alerts traveled across the Minor Planet Center's MPC circulars, rapidly calling the global network of observers to action. Within hours, other surveys turned their powerful eyes to the reported coordinates, including Pan-STARRS in Hawaii and the Zwicky Transient Facility, ZTF, in California. The race was on, not against the object itself, but against time, as its window of optimal visibility was already beginning to shrink. In those opening nights of discovery, the mystery deepened. Initial, crude calculations left room for ambiguity. Was this merely another rogue Oort cloud body? A local comet set free by a gravitational tug from Jupiter or Saturn? Or was it, as the tightening orbital solutions suggested, a true third visitor from beyond our solar system, following in the enigmatic footsteps of Oumuamua and Borisov. The global effort of independent confirmation was relentless. The ZTF's wide-field camera, the sharp imaging power of pan-stars, and soon, observatories in the southern hemisphere, Chile, South Africa, Australia, all stitched together a growing data set. The MPC, the central clearinghouse for such discoveries, meticulously collated the measurements. With each new position plotted against the fixed background stars, the uncertainty in the orbit shrunk dramatically. The calculated orbital eccentricity surged past the unmistakable threshold separating gravitational captives from genuine interstellar wanderers. This confirmation earned the object its designation, 3I Atlas, the third recognized interstellar object 3 to pass through our neighborhood. The velocity, 200,000 nanometer, was not just a number, it was the signature of an exile, hurled by distant planetary gravity, never to return. The realization brought immense urgency. Interstellar objects do not linger. Their speeds are too great, their window of visibility too short. The world's astronomers formed an unspoken alliance, relentless in their coordination, determined to decode even a fraction of the story this shard carried across the dark. In astronomy, windows of opportunity are fragile things, and for 3I Atlas, the window was opening for only a matter of weeks before closing for eternity. Its immense velocity meant that it would rapidly sink into invisibility, fading below the reach of even the world's largest telescopes. The geometry of the encounter dictated a complex, coordinated response. As the object approached its closest point to the Sun perihelion and its Mars-side flyby, scientists globally raced to schedule their instruments. Time on major telescopes is fiercely competitive, but the urgency of witnessing only the third recognized interstellar visitor overruled standard procedures, granting priority access to observational time. Exposure times were painstakingly calculated, and filters carefully chosen to balance sensitivity against faintness. Should they aim for broadband colors to reveal surface hues, or use narrowband filters tuned specifically to gases that might escape its crust? Each choice was a gamble, as the visitor would grant only a limited number of photons, and thus a limited number of opportunities. The observational campaign required complete global cooperation. No single observatory could capture the whole passage. The target had to be passed across longitudes so that as the Earth rotated, another instrument would open its shutter, another camera would hum. Amid this logistical choreography, the deeper truth was evident. Every photon mattered. Each captured streak of light was information encoded by the surface chemistry and history of a fragment that had wandered the galaxy for perhaps hundreds of millions of years. Every photon lost was a secret carried beyond recovery. Why did this visitor, among all objects, ignite such astonishment? The answer lay not just in its foreignness, but in its defiance of astronomical expectation. Humanity had witnessed the two pioneers of interstellar travel. 1I Oumuamua, 2017, elongated, tumbling, and entirely silent, and 2I Borisov, 2019, a comet in every classical sense, flaring with gas and dust. These two sketched the expected boundaries of possibility, a spectrum ranging from a comet with a coma to a silent, inert shard. Yet, 3I Atlas appeared to redraw that spectrum in unsettling ways. Its speed confirmed it was an exile hurled from another system, but its physical character sat uneasily between categories. Asteroidal hint. Its visible images betrayed no dramatic tale, no shining halo of gas. It was faint and dark, suggestive of an inert, rocky body. Cometary hint. Subtle, difficult to confirm deviations in its trajectory hinted at the possibility of non-gravitational acceleration, a telltale sign of sublimating volatile gases characteristic of a comet's icy core. It was neither the flamboyant comet that Borisov had been, nor entirely the silent enigma of Oumuamua. This ambiguity was thrilling and frustrating in equal measure. The neat textbook divisions, asteroid, comet, dormant core, were suddenly porous. If star systems across the galaxy eject fragments of this kind, the very building blocks of planets must be far more diverse than our local examples suggest. The more astronomers examined it, the more 3i Atlas seemed to bend the rules of familiarity without shattering them outright. The rules of motion remained intact, but the rules of identity trembled. It was not fully comet, not wholly asteroid, neither fully dormant nor clearly active. It was something in between, a body that forced the lexicon of astronomy to stretch and flex in search of words that did not yet exist. The cosmos had not betrayed its order, but it had reminded us that our categories are provincial and our definitions are provisional. With geometry confirmed, astronomers focused on the light itself, the delicate flicker that betrayed rotation and shape. Every small body spins, and its light curve, the subtle waxing and waning of brightness as its irregular surfaces catch and lose sunlight, is a historical record of its collisions, ejections, and journey through space. Global telescopes collected these curves, each point representing a fragile photon captured across the dark. The assembled data resembled an erratic pulse, confirming the body was highly irregular and asymmetric. The high amplitude of the flicker hinted at extremes: an elongated shard stretched like a spindle, or a fragment flattened like a disc. This confirmed the object was not a neat pebble, but an irregular fragment shaped by violence and exile. The photometric data also strongly suggested a surface darker than charcoal, absorbing rather than reflecting light. This dark albedo, combined with the absence of a coma, made it resistant to simple classification as a comet. However, the color of the faint light was even more revealing. Its spectrum tilted slightly toward the red, a hue highly reminiscent of surfaces baked by cosmic rays. Objects drifting in interstellar space for millions of years endure a relentless bombardment of high-energy particles. This process, known as space weathering, alters the surfaces into irradiation mantles, dark crusts rich in complex organic polymers called tholins. The reddish tint and dark reflectivity painted a picture of a fragment hardened by exile, its outer layer scarred by eons of galactic radiation. This layer could conceal and protect volatile ices below, hiding them from our eyes. The skin of 3i Atlas told a tale of immense age, but its heart remained veiled. If the visible light provided hints about the surface, the infrared observations promised to speak more directly of size, temperature, and hidden ices. Invisible light. Brightness is deceptive. A small shiny rock can look like a large dark one. Only the body's intrinsic thermal emission, the faint glow of warmth radiated away, can truly disentangle reflectivity from true dimension. Instruments like NASA's NEOWISE telescope and ground-based detectors strain to capture the heat signature of 3i Atlas. Under the thin sunlight of the outer solar system, the shard's temperature hovered near the freezing point of nitrogen. Even this handful of photons revealed much. By comparing thermal flux with reflected light, astronomers estimated its true size, hundreds of meters across, and confirmed its surface was darker than asphalt, radiating weakly. Crucially, the infrared data confirmed the silence. No excess thermal emission betrayed active sublimation. Unlike Borisov, which clearly showed jets of carbon monoxide, 3I Atlas remained stubbornly quiet. This silence was itself a message. It implied a surface crust thick and hard enough, or an interstellar orbit cold and long enough, to suppress any cometary activity. If volatile ices lingered inside, they were permanently locked behind an impervious shell of irradiated dust and carbon. Infrared spectra, though faint, provided more ambiguity. Small features hinted at silicate minerals, the common stuff of rocky worlds, alongside other features suggesting amorphous ices, their bonds stretched thin by cosmic rays. These ambiguous fingerprints tied 3I Atlas to a lineage that was not fundamentally alien matter, but familiar ingredients reassembled under foreign suns. In the red light, invisible to human eyes, the interstellar shard presented the paradox of being both alien and known, both ordinary rock and extraordinary traveler. The persistent question of shape, inferred from the light curve's chaotic rhythm, became a central obsession. No telescope would ever resolve the object directly. It was too small, too distant, and too fast. Therefore, the light curve inversion algorithms were the only path forward, peeling back uncertainty to reconstruct the shadow geometry of this interstellar shard. The results strongly indicated an irregular, non-spheroidal fragment shaped by violence and exile. The amplitude of the light curve, unusually high, made highly elongated or flattened geometries plausible. What was clear was its extreme asymmetrical irregularity. Rotation models added further intrigue. The data suggested a complex non-principal axis rotation tumbling chaos, not a clean single-axis spin. This tumbling motion, the legacy of a past collision or violent ejection, should naturally dampen over time due to internal friction. To persist for millions of years, despite such internal stresses, suggested a structure neither wholly fragile nor fully solid. Perhaps a loosely bound aggregate, or a fractured monolith, hardened by the irradiation crust. Its form was both a relic and a clue, a frozen record of processes from another solar system. Its geometry, like its orbit, refused to be ordinary. In its shadowy outline, inferred from distant flickers, lay a story of shattering forces and endurance across the dark sea of interstellar space. A story humanity could glimpse only in silhouette, never in full, demanding we accept the object as extreme in its asymmetry and motion. If its shape hinted at violence and survival, its full chemistry promised to speak directly of its origins. For astronomers, the ultimate goal was to capture the spectral fingerprints of molecules, the delicate absorption lines that reveal composition. Spectrographs were turned toward it, their prisms and gratings spreading faint photons into rainbow bands. In the faint, ambiguous data, scientists searched for the telltale signatures of volatile gases. Carbon monoxide, CO. If present, it would hint at formation and storage in a frigid, Pluto-like outer region of its native system. Water ice, H2OH, 2OH2, O, or carbon dioxide, CO2CO, 2CO2. If revealed, the shard might once have been part of a common cometary shell, now stripped and scarred. Silicates. If these signatures dominated, it would suggest a rocky inner system origin, a splinter of a planetesimal hardened in the fire of an alien star. The results remained tantalizingly faint. A handful of features suggested weak absorption by carbon-bearing compounds, hinting at possible organics. Other slopes resembled those of Kuiper Belt objects coated in tholins. Yet, nothing was unambiguous due to the object's faintness, the brief observational window, and the interference of Earth's atmosphere. Still, the possibilities painted vivid scenarios. Perhaps this was a fragment of an exo-Pluto, its nitrogen and methane lost, its surface carbonized. Perhaps it was a devolatilized comet, its ices baked away in its native system before ejection. Each option carried profound implications for the diversity of planetary systems. Each a new chapter in the galactic story of how worlds assemble and fracture. The chemical hints carried weight because they showed the visitor was not alien in the sense of being unrecognizable. Its building blocks, carbon, oxygen, silicates, were familiar, yet arranged and processed beyond our sun's reach. In those faint spectra, humanity glimpsed kinship. The galaxy's planets and debris, though vastly different, are fundamentally written in the same cosmic language of matter. While photons revealed chemistry, another line of inquiry probed the object's age, not in years since discovery, but in cosmic time etched into its surface. Every object wandering through the interstellar medium is bombarded by cosmic rays, high-energy particles that pummel its crust, altering chemistry and implanting isotopes. These cosmic rays function as clocks, leaving behind markers of how long a body has drifted between stars. The reddened slope, the darkened albedo, and the possible tholin coating all suggested a long exposure, perhaps tens or hundreds of millions of years. This was no newborn shard. It had sailed the interstellar ocean for epochs far longer than human civilization has existed. Its survival raised critical questions about durability. How could a body so small, only a few hundred meters across, endure the hazards of cosmic radiation, micrometeorite impacts, and relentless thermal cycling for such immense lengths of time? One answer lay in its crust, hardened by irradiation into a protective shell, the space-weathering armor. Beneath this layer, volatile-rich material could remain sealed and shielded. The immense exposure age also hinted at the trauma of its birth. To be cast into interstellar space, 3I Atlas must once have been part of a larger world, ejected by gravitational encounters or collisional cataclysm. The clock that began ticking at ejection thus measured not just age, but the moment this fragment was violently torn free and sent adrift. In contemplating its exposure age, astronomers saw time itself written into matter. Here was a shard older than nations, older than humanity, a survivor that had brushed against the immensity of cosmic history. If exposure ages spoke of survival, the object's hypervelocity trajectory pointed directly toward its birthplace. Orbital mechanicians attempted the delicate work of tracing 3I Atlas back through time, running its orbit in reverse to guess at the region of the galaxy from which it came. The velocity vector was the first clue. Its direction relative to the Sun suggested no clear connection to known stellar neighbors. This was not debris freshly shed by Proxima Centauri or any nearby star. Instead, its inbound trajectory pointed vaguely toward regions of the galactic disk, teeming with young stars and massive planets. Simulations showed that the most likely culprits were outer planetary systems, where migrating gas giants actively scatter debris outward with tremendous force. Over the lifetime of a typical system, billions of such encounters occur, ensuring that shards like 3I Atlas are not exceptions, but inevitabilities. Statistical studies extrapolated from the discoveries of Oumuamua, Borisov, and Atlas suggested that nearly every planetary system must eject such fragments. The galaxy, therefore, is not a quiet collection of isolated stars, but a dynamic ecosystem constantly exchanging matter. The birthplace was less a single star than a population, perhaps a system with an icy outer belt, or a young stellar cluster where gravitational jostling was fierce. Ejection required violence, but not rarity. It was the inevitable byproduct of planet formation. Each interstellar traveler carries the signature of that origin in its chemistry, its spin, and its scarred surface. To trace 3I Atlas backward was to imagine it as part of a planetary nursery, now drifting through our solar system as a solitary witness, carrying in its silence the memory of a star it would never see again. Once the question of origin was raised, theorists focused on the primary mechanisms of exile. How does a fragment like 3I Atlas become unbound from its home star and flung into the galactic sea? Each scenario is violent in its own way. Giant planet sling. The most common suspect involves migrating gas giants. In many young systems, these giants move inward and outward, their gravity scattering smaller bodies like pebbles in a storm. A close encounter can impart enough energy to fling a planetesimal beyond escape velocity, hurling it into interstellar space. The high speed of 3I Atlas is strongly suggestive of this kind of dynamic slingshot. Stellar encounters. Stars are often born in tightly packed clusters. In those first millions of years, neighboring stars pass close to one another, their tidal pulls disturbing the outer debris disks of comets and planetesimals. A fragment nudged at the right moment could find itself cast outward, never to return. Catastrophic collision. If planetesimals collided violently in a crowded disk, fragments might be ejected at extraordinary speeds, some bound, others free. The object's irregular shape and confirmed tumbling rotation strongly hinted at just such a traumatic collisional birth. The conclusion, tentative but compelling, was that 3I Atlas was part of a relentless galactic process, a steady rain of fragments exchanged among stars. Its ejection was not rare, but routine, part of the violent churn that accompanies every act of planetary creation. In this sense, its passage near Mars was a gift not just of chance, but of inevitability. As models of ejection multiplied, so too did more speculative voices. Could 3I Atlas be composed not of ordinary ice and rock, but of something fundamentally exotic? The ambiguity of its composition left room for imagination. Some scientists revisited the nitrogen ice hypothesis proposed for Oumuamua, that it could be a shard of a Pluto-like world, its nitrogen surface eroded by cosmic rays until only a resistant sliver remained. Others considered hydrogen ice, a fantastically volatile substance that could explain strange accelerations, though highly unlikely to survive interstellar travel. Carbon monoxide and carbon dioxide ices seemed more plausible, able to endure long drifts and release faint thrust when warmed by sunlight. Then there was the possibility of ultraporous aggregates, bodies so fluffy and fragile that radiation pressure could nudge them significantly. Such objects would force a reconsideration of how planetesimals assemble, raising profound questions about stability over galactic timescales. More exotic still were whispers of non-natural explanations. While most scientists treated these claims with immense caution, the object's sheer strangeness required considering all possibilities. Could such a fragment be technological, a derelict from some ancient civilization? Oumuamua's puzzling acceleration had once sparked such speculation. For 3I Atlas, the absence of clear radio signals or obvious anomalous structure beyond what natural processes might explain tempered the discussion. Ultimately, the consensus leaned toward the ordinary in the cosmic sense. Volatile ices, rocky silicates, and irradiated organics. But the very act of considering the truly strange was valuable. It reminded the scientific community that discovery sits at the boundary of knowledge, where the familiar shades into the unknown. 3I Atlas may prove conservative in composition, yet its presence alone demonstrated that the galaxy's chemistry is not confined to our small neighborhood. To place 3I Atlas in context, astronomers inevitably looked back to the two wanderers that came before it, Oumuamua and Borisov. Together, they formed a sparse but powerful lineage against which this third visitor could be compared. 1. Oumuamua, 2017. The archetype of mystery. Elongated, tumbling, silent, and accelerating without a visible cause. 2. Borisov, 2019. The textbook comet. Flaring with gas and dust, behaving exactly as a frozen body should. Between these two extremes, the scientific imagination stretched. Some interstellar visitors would be rocky shards, others, icy comets. The spectrum seemed complete. Yet, 3I Atlas fundamentally unsettled this tidy division. It displayed hints of both and commitment to neither. No flamboyant tale, but no total silence in its data either. No obvious acceleration, but no guarantee of purely inert motion. Its ambiguity, its chemical color, its extreme shape, its dark albedo, stood between categories, as though to remind us that our sample of 3 was far too small to define what typical means. This comparison revealed a profound truth. The diversity of interstellar debris likely exceeds even the diversity within our own solar system. Just as Earth, Mars, comets, and asteroids form a family of wildly different bodies orbiting one star, so too the galaxy must teem with fragments representing countless evolutionary histories. One star ejects icy comets, another rocky splinters, another fragile aggregates, another nitrogen-clad shards. The traffic between systems is a mosaic of origins. In this light, 3I Atlas was not an outlier, but a bridge. It connected the mystery of Oumuamua with the clarity of Borisov, showing that the truth lies not in extremes, but in a vast continuum. Each new object shifts the balance, expands the map, and forces science to redraw its expectations. Beyond questions of shape and chemistry lay an even deeper implication. What if interstellar fragments like 3I Atlas carried not just rock and ice, but the very seeds of life? The idea of panspermia has long suggested that the ingredients for biology, amino acids, complex organics, and possibly even microbes, might hitch a ride between stars on such debris. Laboratory experiments and spacecraft missions like Rosetta to Comet 67P have confirmed that amino acids and complex organics can form under the harsh conditions found in icy mantles, bombarded by radiation. It is plausible, even likely, that 3I Atlas also harbors prebiotic chemistry. Imagine a shard born around another star, carrying molecules that might resemble those that once seeded Earth's oceans. Its surface, irradiated and scarred, might hide within it pockets of material shielded from destruction, pockets containing chains of carbon and hydrogen, nucleobases, or other precursors to life. While caution prevails, no evidence suggested microbes and clear amino acid signatures remain far beyond current telescopic data. The hypothesis transforms the meaning of this encounter. 3I Atlas was not just an astronomical curiosity, but a powerful reminder that the galaxy is chemically fertile. It whispered of the possibility that life is not isolated to Earth, but is instead a galactic experiment repeated across billions of worlds. The shard was carrying the echo of another world's potential for life. If 3I Atlas underscored the potential for life's ingredients, it also underscored the profound limitations of our current tools. The observations were fleeting snapshots, glimpses through narrow windows of time. To truly grasp the nature of such interstellar wanderers, humanity requires a new generation of purpose-built instruments. Attention immediately turned toward the future. Nearing completion in Chile, the LSST promises a revolution. With its vast mirror and sweeping surveys, it will scan the entire southern sky every few nights, catching faint, fast-moving objects that present instruments miss. Where Atlas found 1 or 2 interstellar travelers, Rubin could find dozens each year. Its automated data pipeline ensures humanity is no longer surprised, but systematically prepared. NEO Surveyor. NASA's upcoming infrared space telescope is designed to hunt near-Earth asteroids, but it will also excel at spotting faint, cold visitors from beyond. Orbiting away from Earth's heat and atmosphere, it will possess the clarity to detect objects invisible from the ground, dramatically improving the early warning timeline. Comet Interceptor ESA. This dedicated mission promises the unprecedented, a spacecraft waiting in ambush at the Sun-Earth L2 point, ready to launch toward a newly discovered interstellar object. If the right target appears, it will be a net cast across cosmic traffic, a sentinel poised for a direct, close-range encounter. 3i Atlas was both discovery and rehearsal. It reminded humanity of what is possible, what is fleeting, and what must be achieved if we are to seize the chance when the next traveler arrives. The shard near Mars was a teacher, shaping the blueprints of machines not yet launched and discoveries not yet made. The flyby of 3i Atlas also solidified a vision of Mars not merely as a world to be explored, but as a potential platform for observing the galaxy. Earth's atmosphere blurs and absorbs precious photons, while Earth's rotation forces target handoffs. Mars, with its thinner air and quieter background sky, offered a tantalizing alternative, a second astronomical outpost for humanity. Imagine a telescope placed on the Martian surface, its optics trained on the black sky. From there, interstellar visitors could be tracked with a clarity Earth cannot match, extending the observational window. A network of such instruments on Earth and Mars together could triangulate orbits with unmatched precision, watching alien fragments from 2 worlds instead of 1. Mars-based orbiters, too, will evolve. If future missions carry cameras optimized for faint astronomy, every interstellar pass near Mars could become a natural experiment, with shards photographed at close range and at phase angles far superior to anything achievable from Earth. One day, robotic craft stationed at Mars might even deploy small interceptors, swarm probes able to close the gap and capture material from a passing visitor. 3i Atlas demonstrated what is lost when such a visitor cannot be reached, and what could be gained if Mars itself became part of the global observatory. The shard's silent flight across the Martian sky reminded humanity that our exploration of the universe need not be bound to Earth alone. Mars, long a dream of colonists and explorers, might also become the silent partner of astronomers, watching for the next emissary from the stars. The urgency of studying 3i Atlas revealed the evolving, collaborative culture of modern science. Under the immense pressure of a fleeting interstellar visitor, global collaboration became the only viable path. Observatories operating under different nations and institutions shared coordinates, light curves, and spectra within hours. Preprints appeared almost as quickly as the data were reduced, bypassing the long wait of traditional journals. This acceleration carried the risk of error, but it also embodied the agility demanded by phenomena that refused to wait. 3i Atlas would not linger until peer review was complete. Its secrets were locked in photons arriving now, not years later. Science adapted, finding a necessary balance between speed and rigor, openness and caution. Amateur astronomers also played a crucial part, their sensitive cameras and dedicated patience contributing astrometric points that filled gaps left by professional telescopes. The study became both global and democratic, a mosaic of effort stitched from mountaintops, deserts, backyards, and spacecraft. The object itself cared nothing for who observed it, but its legacy would be shaped by the collective will to cooperate. Beneath the logistics lay the deeper, shared sense of wonder. Scientists, students, and enthusiasts alike were united in awe at a shard from another star. In that unity, fleeting though it was, one glimpsed the profound purpose of science, not just to measure, but to marvel, and to do so together. When the measurements, debates, and models were gathered together, a clearer picture of 3I Atlas began to emerge. Not definitive, but coherent. It was a small fragment, perhaps a few hundred meters long, irregular in form. Its surface was dark and reddened by cosmic rays. It bore the scars of ejection and exile, tumbling through space for tens of millions of years. It released no bright tail, yet hints of acceleration and dust suggested it was not entirely inert. It was, above all, a survivor, an emissary of planetary processes we could only infer. The lessons it taught reached far beyond the object itself. First, it confirmed that interstellar space is not empty, but seeded with fragments cast off by alien suns. Our discovery of 3 such bodies in less than a decade hinted at an unseen multitude crossing the solar system regularly. The galaxy is in constant exchange, its systems connected by a quiet commerce of matter. Second, it reframed planetary science. Each shard is a probe from another laboratory, evidence that planetary systems everywhere endure chaos, collisions, and expulsions. To study 3I Atlas is to learn not only its chemistry, but about the universality of planetary violence and the richness of outcomes when stars build their families of worlds. Finally, it sharpened our awareness of time. Objects like this move fast, fade quickly, and vanish forever. The window to study them is measured in weeks. Preparedness, coordination, and humility are essential if humanity is to seize the chance when the next traveler arrives. In its faint trail across Mars's orbit, 3I Atlas reminded us of the fragility of knowledge and the grandeur of possibility. We could not capture it, could not visit it, could not hold it in our hands, but we could glimpse it, measure it, imagine it, and in so doing, expand the map of what it means to be a planetary system. Adrift in a galaxy, alive with fragments. In the end, there was nothing more to do but watch it fade. 3I Atlas slipped past Mars and into the deeper dark, its magnitude falling night by night until it vanished beneath the limits of our most powerful eyes. The hyperbolic arc carried it outward, past Jupiter's pole, past Saturn's pale rings, toward the edge of the heliosphere. Astronomers marked the final observations with quiet reverence. Each data point, the last of its kind, was archived not as closure, but as a beginning, a record to be revisited when the next visitor arrives. The object carried secrets we could not crack. Its birthplace, its exact composition, the full truth of its inner structure. It withheld as much as it revealed, and yet, that withholding was itself a gift. It reminded us that science thrives not on easy answers, but on questions that linger, questions that compel us to prepare better, to look harder, to wonder more deeply. The story now softens, the pace slows, and the words drift like dust across the last light of the visitor's trail. The frantic chase of observations, the urgency of brief nights, all recede into a calm reflection. What remains is the image of a shard, small against the immensity, moving steadily outward until it is gone. Its silence is complete, but not empty, for in its passing, it left us richer, with questions sharpened, with instruments tested, With imaginations awakened to the traffic of the stars, the mystery is not solved, but it is shared. The stars remain patient and unhurried, waiting for the next emissary to arrive. Until then, the silence is not a void, but a cradle carrying both questions and peace. The story of Three-Eye Atlas is just one thread in the vast tapestry of the cosmos. The universe is full of such mysteries, waiting for those with the curiosity to look. Don't let the wonder end here. Subscribe and turn on notifications so you can journey with us to the furthest reaches of scientific discovery. Together, we will keep watching, keep questioning, and keep dreaming.